Hello everyone, I hope you're doing well and welcome to the platform of CodeChef. So, today we'll be doing the problem Harry and Chocolates, whose difficulty level is simple to easy and the prerequisites for the problem are binary search. And this is your educator Ansh, so I hope you like this video. And let's move on to the problem statement. Okay, so first of all, I request you all to kindly read the problem statement, understand it carefully before moving to the solution. Okay, so now let me summarize the problem statement for you. This question, we are given two information. Firstly, a chocolate array like 1, 2, 3, 4, 5 is the amount of chocolates that we eat for each day. So on first day we have eaten 1 chocolate, on second day we had 2 chocolates and so on. Now, let's calculate the array for over the period of time. So like on one day, I ate 1 chocolate. In the first 2 days, I ate 1 plus 2, which is 3 chocolates. In the first 3 days, I ate 1 plus 2 plus 3, which is 6 chocolates. And similarly, on the first 4 days, we ate 10 chocolates, and in the first 5 days, we ate over 15 chocolates. Okay, so now the question is giving us a query array, which is 3, 8, 10, 14. And this query array is signifying how many chocolates have we eaten up till that day. So example 3. So for 3, as you know, we ate 3 chocolates. We ate a total of 3 chocolates for the first 2 days. So the answer for this particular query is 2, because we ate 1 chocolate on the first day and we ate 2 chocolate on the second day. So we had total of 3 chocolates in the first 2 days. And so it took me 2 days to eat for 3 chocolates. Similarly, the next query is 8. So here, as we can see, we are eating 6 chocolates in the third day, like in the first 3 days, and we are eating 10 chocolates in the first 4 days. So obviously, it will take me 4 days to eat 8 chocolates, because till here, we have eaten only 6 chocolates. So it takes me 4th day to eat. So the answer for this particular query is 4. Then for 10, we can see that my 4th day we have eaten 10 chocolates, so the answer for this is 4. And similarly for 14, I know that since I ate 10 chocolates on the first 4 days and I ate 15 chocolates on the first 5 days, then my answer for this particular query is 5. So this is what the problem is asking, that you're given an amount of chocolates in total and how many days did you take to eat them all. So yeah, let's move on to the abridge for this particular question. Okay, so now let's understand a very important observation in this question. Consider my query of 8, like for how many days have you eaten a total of 8 chocolates? Now, just consider the first 3 days. In the first 3 days, I ate a total of 6 chocolates. And in my first 4 days, I ate a total of 10 chocolates. So obviously my 8th chocolate would lie on my 4th day, like somewhere when the 4th day was going on, I ate my 4 chocolates, and that's when the 8th chocolate would have eaten. So the answer for any particular query is the number just greater than or equal to that particular query. So in this case, the answer is, if I take 8, so any number which is greater than equal to 8 in my sum array and the position of that particular number. So in this case, the number is 10 and the position of this number is 4th, and hence we took 4 days to eat that particular problem. Now the point is, how do we find the position of this 10 or the number just greater than equal to the queried number in the minimum time complexity? The answer for this is binary search. Let's see how we can apply binary search on this. Okay, let's see how we can apply binary search in this particular problem. Now for that, let's just use this example case only. So it's 1, 2, 3, 4, 5. My sum array becomes 1, 3, 6. And sum array 1, 3, 6, 10, 15. And let's say my query is 8. Okay, so now according to the algorithm, firstly in binary search, we always initialize my starting point as a start of array and my ending point as the end of array. So in this case, my starting is 0 and my ending is 4. So every time we compare the mid and we calculate the mid, as 0 plus 4 by 2, which is equals to the second element. So 6 is my middle element. Now we compare 6 with our original array. So is 6 greater than or equal to 8? So no, it's not. So that means the idea of binary search is if 6 is not greater than equal to 8, that means the array elements before that won't be greater than equal, like would definitely not be greater than equal to 8. Hence, we can discard this entire portion of array. So here I had my starting pointer left, here I had my ending pointer right, low and high. And since if my 6 is not greater than 8 and all elements before are less than that, I am assured that none of the elements left on the left side than 6 will be greater than my 8. So I can put my left pointer directly over here, considering that only these elements are possible for my required answer. And why we can apply binary search? Because we are taking the sum array. So if we take the sum array, the final configuration that we get will always be sorted, because every time we are adding a number. So first we are adding 1. So then we are adding 1 plus 2. Then we are adding 1 plus 2 plus 3. So obviously, or every time 1 will be less than 1 plus 2. 1 plus 2 will be less than 1 plus 2 plus 3, and so on. If we add any positive integer, we will always get a sorted array. And because we get a sorted array, we can cross out the possibility that if this condition is not fulfilling, obviously the elements that are smaller than that won't fulfill this particular condition. So this way I trend my low and high here. Now again, the value of low has become, this is third element and this is fourth element. So again we get our mid as 3 plus 4 by 2, which is 7 by 2, which is 3. We take the floor value, right? So now I check whether my third element is 10. So now I check my 10 is greater than equal to 8, and yes, it is greater than equal to 8. So I initialize my answer as this position, which is third position, and then I convert my, since this is current, so I convert my high onto this particular element. So my high will be also initialized as 3, and then my, why am I initializing at 3? Because if 10 is greater than equal to 8, then all the elements greater than this will obviously be greater than equal to 8. So this becomes my number just greater than equal to 8. And then my low will also be 3, my high also will be 3, and my binary search will be terminated, giving me the result as 3. But this 3 is on 0 based indexing, since I considered 0 as my lowest point and n minus 1 as my end point. So we can just increment 1 to get 4 as our answer in 1 based indexing, because in array the index starts from 0, but in number of days starts from 1. So we can just increment 1 to get our answer. So the answer is 4. So using this binary search algorithm, we can get our required element in the time complexity of big O of log n, because every time we are cutting n by 2 of the array. And yeah, doing this, the time complexity turns out to be log n. So yeah, this is the approach for the particular problem. Let's move on to the coding section. Okay, now let's get on to the problem and see how to code this. So firstly, we took all the required NNM as the input, which is the length of array and the number of query elements. Then we took the array input, and then we computed the sum array or the prefix array for this particular problem, as we did in our approach section. Then we took for each query, we took the variable input, and we started our binary search algorithm, initializing the low as 0, my high as n minus 1, and my required answer is 0. And then we applied the exact algorithm in which we calculate the mid. We compare our current element with the queried element. If it is greater than or equal to the queried element, then we can discard the half portion of the array. And if it is not, then we can discard the other half portion of the array. And after the completion of the binary search, we'll have a final answer. So let me just run and show you if the code is working or not. Okay, so as you can see, we have final answer as 2445, which is correct and it is given in the question. Now let me submit the particular code and see whether it is working on actual test cases or not. Well, also I would like to point out one wrong answer or one time limit exceeded error and what the person did wrong in this question. So firstly, when in this person did not apply binary search, he just did the linear search in order to find this. So he got the time limit exceeded error. The point being, if you do a linear search for element just greater than equal to the required number, then the time complexity becomes q into n. But by binary search, we can optimize the complexity into q into log n. So yes, the solution becomes very efficient and it gets accepted in the required complexity. But if you do it in linear, then you might get a time limit exceeded error depending upon the constraints. So whenever the constraints are tight and near 10 to the power 5, you should always think of binary search for queries if it is possible, so that you could accept a solution in q log n or time complexity which is optimal than that. So yeah, I hope you like my video. Please like, share and subscribe to our channel. Thank you.